Hi, this presentation covers linear search and implementation of linear search. So, before we discussing linear search, I will introduce myself. I am Mr. K. Venkateswara Rao, Head of the Department of Computer Science, Hebrew Engineering College. Okay, first we go for what is linear search. What is searching? Searching is used to determine the given element is in the list or not. That's we call as searching. Actually, there are different types of searchings like linear search, binary search, Fibonacci search. Like among all the searching methods, linear search is the easiest method or simplest method to search the given element is in the list. In this method, the element is compared sequentially until the element is found or the list is empty. That's the main procedure we are used in linear search. That is, so the element is compared sequentially or linearly until the element is found or the list is empty. So let us we take an example. Let us assume that there are 10 elements 10, 50, 30, 70, 80, 60, 20, 90, and 40. The key element is 20. I want to set this 20 element in this list. First, the key element 20 is compared with 10. When both are equal, no. Then we compare the key 20 with 50. No, it's not. Again, 20 is compared with 30. No. 20 is compared with 70. Not. 20 is compared with 80. Not matched. 20 is compared with 60. Not matched. 20 is equal to 20. Yes, the element is found. So that means we are comparing, first we compare the zeroth element, after that first element, after the second position element, after the third position element, fourth position. Like this we can compare the elements sequentially until the element is found. So this is the implementation process in linear search. Then the time complexity. What is the time complexity? See, actually, we take time complexity, best case, worst case, and average case. The best case time complexity is 1, order of 1, because the first, if the key element is the first element, then the time complexity is order of n. Worst case, if the key element is the last element, the time complexity is order of n. Average case by taking both the order of n also. So this is the way to calculate the time complexity. Then we can go for how to implement this linear search in C++. So in order to implement the programs in C++, we require the header files hash include iostream.h. This is the header file required for both input and output. That's why we are using iostream. This header file is required whenever we are using input and output statements in C++. Hash include conio.h. So this is the header file which is used for clear screen like this. So we are implementing the program in C++. Actually, C++ is a bottom-up approach method. So, whenever we are using bottom-up approach, there is no need of prototypes. So when we are implementing top-down approach, we required so for function prototypes as a wish. So whether we are implementing either top-down approach or bottom-up approach. Suppose I am implementing top-down approach, so I required a function prototype first. So int The function name is linear search int int. It has three parameters. This we called as a function prototype. This is function prototype. A function prototype will instruct the compiler the name of the function we are using, the return type of the function, the number of parameters, and the data type of the parameters. This prototype will instruct the compiler the name of the function is linear search. The return type of this function is an integer. This function has three parameters. All the three parameters are an integer data type. So void main. So I'm using one global variable int I because this variable is required throughout the program. Void main. So then declare the variables. Then int a of 10. A is an array which can hold maximum of 10 elements. N number of values to be stored. Key again is found. These are the variables required for variables required. CLR is CLR. First of all, you have to read the number of values of the array. Cout is the statement, is an output statement. Cout, enter the number of values of the array. Cout, enter the number of values of the array. Seen here, n indicates the value, the number of values to be entered in the array. Suppose if the value of n is 5, so an array can hold 5 elements. If the value of n is 7, an array can hold 7 elements. If the value is 10, then array can hold 10 values. The n value cannot exceed 10 because the size of the array is 10. Then read the values into the array. Cout. Enter n integers. Seen. Oh, sorry. So to read n numbers, we use for loop for I equal to 0 because the starting position of the array is 0. I less than n, I plus plus. Seen E of. So I read n elements into the array. After that, set the key element, enter the key element, Cout, enter key element. Seen. Then I will call the function linear search and the return value of this function is assigned to the variable found. Found equal to linear search a comma n comma key. So I am passing three parameters a, n and key. A is an array, n is the number of values of the array, key is the searching element. The return type of this function is assigned to the variable found. If found equal to 1, if found equal to 1, so indicates the key element is in the list. Cout. The element is in the list. Else, otherwise, the element is not in the list. So this is the main function. So in main function, I read number of values, array, then enter the values into the array, then I call the function and print whether the element is in the list or not. Then go for implementation. In return type of the function is int. The function name is linearsearch. Linearsearch int a of 10. A is an array which contains 10 elements. Int n, then int key. These are the formal parameters. So in function call there is an actual parameters. So there must be an equal number of actual and formal parameters. So in function call there are 3 actual parameters. Similarly in function definition also there are 3 formal parameters. The names of the formal and actual parameters may or may not be same. However, there must be an equal number of parameters. So the setting will start from 0 to 0. That's way we start. We assign I equal to 0. I am assigned I equal to 0 because the setting will start from 0 equation. I equal to 0. Then we compare when the element is not in the list. When we say that the element is not in the list after comparison of n elements, that means while I less than n, continue the process until to set all the elements. That's why I return I less than n. If a of I array element array ith element is equal to key, I return 1. Else I'll compare the next element. The next element is I plus plus. So I return 0 when the element is not in the list. So the process is in the process. First, the searching process will start from 0. That's why assign I equal to 0. Then, so we compare the elements until the element is empty. So if I less than while I less than n, so yes, if a of I equal to key array element is equal to key element, then I return the value 1. Otherwise, I compare the next elements. So this is the way. Then go for compilation. So this is the output screen. Enter the number of values of the array. So I entered 6. So enter 6 integers. So I entered so the letters of the 6 integers are 3, 4, 5, 6, 7, 8. These are the 6 integers. Then compare the key element. Enter the key element 7. Says the element is found in the list. So this is the positive, so true case, true testing case. So for each program, it is necessary to test both true and false side. So whether the element is in the list, whether the element is not in the list. This is the true side. The element is in the list. Suppose if I entered the element is not in the list, number of values of the array. So enter 5 elements, 1, 2, 3, 4, 5. Then enter the 6, 7 key element 7. So the element is not in the list. Yes. So this is the method to implement linear search. So this is the method. So this is the way to implement the linear search in C++. So this program is written in functions because so in C++ in the data structures, all the programs will contains number of modules. All the modules are must be implemented in functions only. So we can implement either top-down or bottom-up approach. Here I implemented a top-down approach. So whenever using top-down approach, it is necessary to implement, it is necessary to write so function prototype. Whenever you are using bottom-up approach, no need of function prototypes. So this is about linear search. So thanks for watching.